Hello, everyone, and welcome back to our series of webinars for the launch of the new version of Comosys. Last week, we got an amazing response from everyone who attended the steel detailing webinar. I was hesitant to create a webinar lasting almost 2 hours, but to my pleasant surprise, some of you actually watched even that long video more than once to understand it better. Now, that shows that our audience is receptive and they like what they're seeing in Comosys. What it also shows is they want change. So, emboldened by that wonderful experience, I decided not to hold back and try to show you as much as I can today as well. So, today I'll be talking about concrete modeling. Today I'll be talking about rebar modeling. And today I will also be talking about concrete and rebar drawings extracted from the 3D model. Now, I know from our research that the concrete and rebar industry hasn't really embraced 3D modeling the way the steel industry has. And there are many reasons for this. Some are technical challenges, while others are merely psychological barriers which get in the way of decision makers. I will try to present Comosys to you in such a way which relieves both your technical as well as psychological fears. I will try my best to make modeling look like a walk in the park. I'm hoping to win over many new converts today. I'm hoping you will leave this webinar having decided to give 3D concrete and 3D rebar a chance. I'm hoping that concrete lovers will not stay behind and give their steel brethren a run for their money. But most importantly, I want you and your business to benefit from 3D modeling. If you can reduce your man hours by just 20%, you can perhaps double your profits. But I'm here to tell you that with the right skill sets, you can reduce your man hours by half, if not more, if you use 3D modeling for both concrete as well as rebars. And that's not all. The quality of your work will also skyrocket. That's what 3D modeling is supposed to do when done properly. So let's start today's presentation. Now let's create some simple beams and columns, and this is not really the area in which one program would typically excel over another. We can just copy a column around, for example. We can enter some beams, use the same copy array command to copy it across the columns. Obviously got one more copy. If you use the same numbers, I can delete the last part, which is extra, and I can then zoom in and enter the beam on the other side, use the same copy array method to copy the beams as well. Then I can delete this extra one, and then I can look at it from the side. For example, I can maybe delete a part of the building like that. Maybe if I want, I can select the joints only, and after doing that, I can just copy call the move command and move them up a bit. Secondly, I can maybe delete this part of the building, make some movement, make it look a bit different from a standard copy. So this part up till now, what you've seen is pretty much this kind of data entry for normal buildings, for high-rise buildings, for any kind of building. That's very simple. It's when you get to the more complicated stuff that modeling starts consuming time. If it's only beams and columns and you're copying them around even 100 stories, that's not really much of an achievement. But when you really get to industrial type buildings with lots of holes and channels and whatnot, and I'll talk about those in a second, that's when you get problems, and that's where one program will be different from the other. Now let's create a slab. So all we do is just select any number of points, at least 3. You can't enter less than 3. But if I'm going to select 4 points, and a slab will be created immediately at the floor level on which I'm working on. Now, one requirement, especially in industrial type buildings, is to have slab openings. So all we do is just go to the slab opening command, select our slab and select a point, and immediately an opening is created at that point. Now I can double click on this and a dialog box appears. So it's not just a dummy cut over there, but I can actually give various sizes to this opening. So let me give these two sizes over here and say apply, and immediately the size of the opening is changed, as you can see in the 3D view as well. Let me remove the cuts from the 3D view so that you can watch it more clearly. Another thing I can do is I can double click it again and I can give it an angle. So if I enter 30 degrees over here, you will see that the cut which was created is then turned at an angle of 30 degrees. Another thing which we can do is convert this into a circular opening, for instance. So if I press this one, it converts it into a circular opening. I can bring it back by removing this flag, and that's as simple as that. Another very nice feature which I have is I can double click on this opening and I can say create a parapet around it. And when I do that, this little parapet is created around that opening as a separate intelligent object, by the way. So if I double click on that parapet now, I can give it the dimensions which I want. So I can make this 500, make this 300. That'll change the dimensions of the parapet, as you can see on the screen. Or I can go inside again, and I can even give thickness, width over here. And this, what it does is it creates a little place over here for some covers to come, which are very typical in industrial type structures. You can have a cover over here, and that cover will need to sit on that concrete. So imagine normally if you were doing this with manual detailing with lots of cuts, you would have spent probably about 10-15 minutes just getting this parapet in order. But that's not all. If I continue double clicking on the parapet, I can even ask it to create a cover for me. And there you go. My concrete covers for my industrial structure are there. And I can modify these, and I can, these are customizable. All sorts of customizations are available. But the point I'm trying to make over here is that the simple command of creating a hole in the slab, which we started off with, has led into so many details that that little hole converted into a circular hole or any other sized hole, or you could make a parapet around it. You could give it certain dimensions. You can create a cover around it. So within a few clicks, and all these are actually hindrances in other commercially available modeling software, because just doing this is finalizing this little hole will take half an hour, and typically detailers will shy from that. But in Comosys, you're free to do this kind of detailing very, very quickly. Now, instead of creating the parapet, which we just did, we can just directly create this little depression directly on that hole as well. So if I were to enter that, we can see that instead of the parapet, directly I've created this depression so that a cover can come directly in this on top of this hole. And this simple hole command doesn't even end there. I can even give chamfers. So if I give 4 chamfers to the corner points, I can create this sort of a chamfer around it if I wanted to. Or I could give it a different type of a chamfer if I wanted. I could remove this one, and I could give point number 1 a circular chamfer, and a totally different kind of an opening would be created. And it's not even that only. I could just double click on this, create a small hole, for example, go to my this chamfer tab, and I can have a grid of holes if I wanted to. I can have them in both directions. So by the simple cut command, I've created several holes in that slab in one go by just modifying the parameters of a single command, which we used for creating slab openings. So you can see that this kind of versatility is extremely useful when you're dealing with complicated situations, industrial plants, and your normal modeling techniques, while available, do take up a lot of time. But with Comosys, you can do the same stuff very, very quickly. And this is the reason why people give up modeling in concrete, because they feel that while entering just beams and columns is pretty quick, but actually getting down to the individual anchor bolts, anchor boxes, holes, and this and that, there's too much time to be lost, and they'd rather do it in AutoCAD. But with Comosys, you can actually exceed the speed of AutoCAD by multiples if you're good at using it. And there is even more to show you, but I just want to move on and just going to talk about it for a second. So, around these holes, you even have these strengthening rag bolts at the corners so that the corners don't break off. And they can be modeled directly from within this command. So what started off as a very simple command to create a hole in a slab has ended up creating everything around that hole as well, which is obviously necessary if you want going to complete the building and if you're going to extract your 2D drawings from it. Because if you don't do this modeling, what will happen is that your 2D drawings will be incomplete. And once they're incomplete, you will have to finish them off in AutoCAD. And once you start doing that, and then there are revisions and more revisions and more revisions. So eventually, what happens is your model gets severed off from your drawings completely. So the idea behind 3D modeling is that you should model everything in the 3D model, not just half the building or part of the building. Because the moment you start modeling a part of the building, it comes back to haunt you, and eventually your model will be broken from your drawings, and that'll be the end of it. But with Comosis, you don't need to do that. You can actually model right down to the final rag bolt and get on. Now let's enter a few walls. So I go to my wall button and I select 2 points basically. And the moment I do that, you can see on the 3D view that the wall has been created. Let's continue on the other side and create the wall over there as well. Now, as you can see over there, the height of the story is different. The height of the building is not the same as this side. So I just double click it and I change the top level to 5,000 and my wall has been finalized. Now, if I open up the dialog box again, you can see that we have complete control over the top level of the wall, over the bottom level of the wall. So if I specify this to be, say, minus 2000, then the wall will continue 2 meters down as well. So I have complete control over that. I have complete control over the thickness of the wall. I can give the height directly or by giving the elevation. I can give it some start and end offsets if I wanted to. And there are some, once again, details for the top of the wall. Once again, all these are features which save time. So sometimes if there's something sitting on top of the wall, you can create this kind of a feature at the top by directly entering some numbers instead of going through the normal procedure of using the cut command, etc. And it's very easy to use, as you can see on the screen. Just enter 2 points and your wall is ready. Now, let's say there's an architectural requirement to create a window opening about, say, 1 meter back of this axis over here. So I just go to my windows and doors opening. I select the wall, and then I select this point over here, and I just press enter, and I say dy minus 1000 because that's the point I want to select. And the moment I do that, my window open is created exactly at 1 meter from that access point. And then I can just double click on that and I can change the level, the height. For example, right now it's at 8 meters. The top level is at 8 meters. I can change that to maybe 8,500 if I want to. What I can do is I can change the size of this opening, just like we did in the other command. I can make it wider. I can make it I can change the other dimension as well if I want. I can even go over here and create an entire grid of window openings, for example. I can just enter distances just like I enter grid distances over here. And I can make 20 copies of these along the wall if I wanted to. Once again, I can give chamfers as well to the corners. So it's pretty detailed, and you can do a lot with this command as well, just like we could do with the other one. And you can even have a parameter over here. For example, if I were to enter 100 over here, I can even create a partial opening. What that means is if I turned off the cuts, for example, it can just create a depression in the wall, not a hole right through the wall, but just a depression. So there's a lot to do. There's a lot these commands do. They look like simple commands to create openings in slabs and walls, but they can be used to create openings of all sorts and with different details. In concrete modeling, we usually have continuous walls. So these are not walls which you can create with 2 points, but you need multiple points to define them. And we can do that very easily with the folded plate command in Comosys as well. So let me just go through a few points. Let's go like that and right click, and immediately a wall is created by the default settings. Now, this is a bit more than just a normal classical folded plate, which you might be used to. What you can do is you can double click on the wall, and you can go to the chamfer section. And this was point number 1, 2, 3. So you can go to point number 2 and give it a say a chamfer of 2000. And when you do that, you get that chamfer. I can continue. I can give the point number 3 a chamfer of 2000 as well. I can continue, and what I can do is I can ask for the outer chamfer not to be created. So when I do that, you can see on the screen that the inner chamfer has been created, but the outer chamfer has been omitted. The inner chamfer has been created and the outer one has been. So you can have these architectural requirements, and by the same folded plate command, which normally doesn't do these kinds of things, you can create walls of this kind of variety. Another thing which is very useful is that you can actually, normally in a folded plate command, the thickness is constant across the wall. But I can ask it to do a thickness of 500 millimeters for the first leg, 1000 millimeters for the second leg, and back to 500 for the remaining legs. And when I do that, you can see that it starts off with a thickness of 500, turns into a thickness of 1 millimeter, back to 500 for the rest of the remaining legs. And I can just go back in and even say that do that only for the third leg, and from then on just really make it a really thick wall of 1.5 meters. And immediately on the screen you see that you've got this variable thickness wall created by the same um, folded plate command, which can also be used for steel structures. But over here with concrete structures, these kinds of walls are not necessarily very uncommon. You can find them, and whenever you do, it's very easy for you to model them in Comosys. Now, just like we saw that how easy it is to create holes and then modify those holes or multiply them in the form of a grid, similarly, in industrial buildings, pits are also very common, which is that when in a slab you have an opening which then converts into a little pit over there, and there's a bottom slab which is lower than that slab, and there are 4 walls around it, and that takes up a lot of modeling time for most people. So in Comosys, what we have done is we've provided a direct command for that. So all you need to do is just select the slab and select the point, and immediately a pit is created, as you can see on the screen. And you can see that it has the 4 walls around the pit and the slab which forms the bottom of the pit. And if you double click on any of those members, you can do complete any kind of modification regarding the depth, the bottom level. You can create multiple pits at the same time. All these parameters which you see on the screen, you can change the size of the hole. Now, normally, typically a detailer would first create a hole, then create the 4 walls, then create the bottom slab. And if there's a revision regarding the heights or anything, then everything would need to be changed. But in Comosys, it's very easy to just do that. And you can also, once again, you have your chamfer parameters and your other geometrical parameters to play with. You can even create a circular opening if you wanted to, and you can create the walls as divided walls or as one single. That would depend on how you want to number them. Now let's quickly select the bottom floor columns, press enter, select our profiles through on-the-fly filtering, double click, and once we get the columns, we can move the bottom to 2 meters below the 0 level, and the top can remain the same for the ground floors, and all the columns by this single motion will be moved 2 meters down. We can once again move the walls as well. We can give these a level of minus 2000 as well. Same for the side on the other side. And once we are done with that, we can go to our simple pad footing command and select the column, and the pad footing is created. We can select the pad footing, copy array, and in the same way we did with the columns, you can just copy the pad footings And in a few clicks, we've gotten the foundation system ready almost as well. Now, with a few clicks, we can create our tie beams between these pad footings, for example, like that, just by selecting the two pad footings, and then copy that with the array command as well. And if we just press copy, they will be copied in that direction. And then we can continue for the other direction as well. We can create a tie beam between these two, select it, and do the array copy. But this time we do 4 copies in the X direction and 3 copies in the Y direction. And we just say copy. And with a few clicks, we've gotten the tie beam system ready as well. Now, as you can probably tell by now, modeling in Comosys is quite easy, and I'm going to continue doing that. For example, let's model a few stairs. I'm going to select a few points, right click, and once again, select a few points and right click. And as you can see, it's not that difficult. If I just double click and do some modifications, you can see I'm doing it as you're seeing it on the screen. With a few clicks, you can create the staircases as well, and then you can copy them to the other floor. For example, let's now copy them 5 meters above, and we get the second floor as well. So with a few clicks, like you saw on the screen, you are able to create your staircases and then connect them to the beams and the columns. And as you're doing it, the model is being created. And what I mean by that is that if you notice right now, all these are separate pieces. They're not monolithic. But what Comosys does automatically is it converts them into a monolithic piece of reinforced concrete. So it becomes one piece when it comes to the drawings. And if you notice right now, I haven't given any detail to the clashes. Everything is clashing with everything. This beam is going inside the column. This staircase landing is going inside the beam. The slab is going inside the beams. The walls are going through the beams and whatever. So there's a lot of clashes going on right now. But all those clashes will be sorted out once we go to the drawings. So if I was to go to the drawing side right now and open a drawing, which is basically I had created some views, but the views were empty because I didn't have any model. But now the views have been filled up because I was doing the modeling in front of you. So as you can see, everything has become monolithic and has become one piece on the drawing side. And we'll talk a lot about this later on. But I just wanted to show you that as we are doing the modeling, everything is being connected, and it's becoming one monolithic piece in concrete. So this is a section taken there. You can see the stairs. I have the section over here. If I move the section from here, if I take it from here to some other location, immediately that section over there will be modified according to the new location. And basically the point being that the drawings are completely connected with the model. They have not been dimensioned yet. They haven't been annotated yet. We'll talk about that. But at this point, what I want you to notice is that it has become one monolithic piece, what was many small pieces or many individual pieces on the model side. Now, I've been emphasizing throughout the webinar that if you want to do 3D modeling, you have to do it completely. You can't do it partially. And everything needs to be modeled. And once again, in concrete also, the steel industry is fairly used to this, but the concrete industry, unfortunately, is not. And what they do is they typically try to model as much as they can, and then they switch programs and they move on to AutoCAD and finish the job in AutoCAD. But this is not the right way to do it, and Comosys will encourage you not to do that. And so, for example, one thing which you might notice is incomplete right now is the lean concrete under the foundations, which needs to be poured. And you might be thinking, oh, that's going to take a lot of time. There's so many foundations and tie beams, all of which will need lean concrete under them. But I'll just show you how quickly it can be done. You just select this bottom area, press enter, press the plates, and you can group them in different ways. I have selected the tie beams and the single footings like that. And after having done that, let's just go to this lean concrete command over here and just press it. And the moment you do that, just look what happened. These pink lean concretes have been modeled under the foundations with a single click. This would have taken you hours and hours to do maybe. But with a single click, all the lean concrete has been modeled, and now that it's been modeled, it's going to show up in the drawings as well. And it's going to show up not this is not going to be unioned with the main cast in place concrete. This is going to be a separate union. It's going to turn up as a separate object, and there'll be a line over here. Normally, if, for example, if it was all going to be unioned, they would merge into one piece. But in this case, the program intelligently knows that the lean concrete is a separate object, and we'll see the results of that later anyways. But what I wanted to show you is how quickly and how efficiently ComAssist will help you literally in a few seconds model your lean concrete. Now let's talk about drains and channels, which are very common in concrete industrial buildings, and they're used for different purposes. And there would be a drain going along a slab, for example, collecting some fluids or draining them out for whatever reasons. And they're usually very difficult to model with cuts because of their shapes and the way they're. So in ComAssist, what we have are specialized commands, specialized cut commands. So let me just select this slab and right click, and then let me just show it a path. It's going to select a few points. Point number 1, 2, 3. Let's go like that. Let's go to the mid. Let's come back over here, and let's go out from there, and then right click. Now, the moment I do that, you see on the screen that this channel, let me just close the cut so that you can see it better. And yeah, so you can see that this channel has been created all along that path which I showed with a few clicks, just by selecting the points. And normally, if you were to do this by using the normal cut commands present in typical commercially available softwares, then this would be pretty time consuming. And this is not all. If I were to just double click on or open up the cut, for example, and double click on that, you would see that there's a lot more going on over here. For instance, I've got control over the thicknesses of these or the widths of these channels. So I can enter 500, for example, and if I press apply, the width of the channel changes. But I can also press 500 and say 1000 and then go back to 500. And in that case, the second part, the second leg of the channel has a width of 1 meter, and then the rest go back to 500. So this gives me even more control over what I can do with the command. Another thing which I can do is I can turn on these little boxes over here. And when I do that, the ends have been modified, if you can see. So this kind of a detail is pretty common. And wherever it's pouring into the final detail could be something like that. So imagine doing that by using the classical cut commands in ComAssist. That would take you a long time. But the presence of such dedicated cut commands will really make your job a lot easier. Another thing which I can do is I can give chamfers. So this was point number 1, this was point number 2. So I can go to my point number 2 and give it a chamfer of, say, 1000 by 1000. And if I do that, you see that this chamfer is created over and above my original definition. There is even more I can do with it. Here I have complete control over the inner chamfer and the outer chamfer. So if I want, I can ask the program not to create the outer chamfer. And if I do that, you see that the outer chamfer has not been created, but the inner chamfer has been created. And this is something which might be the requirement of your particular design requirement. So this is, as you can see, this creating these kinds of cuts, while it's possible to do them using the normal cut commands as well, but having commands, dedicated commands like this, will really make your job as a detailer much easier. Here is another trick which you can do with this very same macro. If you can use this little checkbox over here to create the covers that we've been talking about. So if I turn this on, for example, and I press OK, and I turn off the cuts, you can see that ComAssist has created covers for the entire drain all along the way. And these are customizable, and you can modify their locations and the types of handles and this and that. There's a lot of detail, which I can't go into right now. But the point being that with a single command, just by selecting point 1, point 2, point 3, 4, 5, 6, 7, you have created a very complex detail which then allows you to go directly to the drawing side and create the drawings automatically from this model, instead of taking it to AutoCAD and finishing it off in AutoCAD for details such as these. Galleries are very common in industrial plants, and these could be underground galleries or overground galleries, depending on the situation. And they're typically used to carry pipes or electrical cables from one point to the other across the plant. And you have this is what they typically would look like. So let me set the origin of interest somewhere over here, and so it's basically a gallery. And what you have is you have these cable raceways or pipe supports coming from the sides of the walls on which the pipes or the cables actually eventually run. Now, creating this, of course, is slightly time consuming depending on the geometry. But in Comosys, let me just delete this one which you see on the screen, and I'll show you this dedicated command for galleries. All you need to do is just select point 1, point 2, point 3, point 4, and right click, and your gallery is created. If you double click on the gallery, you have complete control. Once again, you can modify the thickness, this width of the gallery. For example, so if I wanted the width of 1 meter, but then I wanted the second one to be 2 meters and then back to 1 meter, then I could just do that like that, and immediately this is 1 meter, this is 2. Let me just increase that a bit more so that it becomes more pronounced. Let's make it 3 meters. Yeah, so you can see it better on the screen now. So the gallery has widened in that area, and then it's narrowed once again. So this kind of control you have from there. You can obviously change the points around which it's anchored from those parameters. Using those parameters, you have complete geometric control, as you see, over the size of the gallery, etc. You even have these starting the widening of the gallery at the start, at the end, options to do that. It's very easy to see that doing this manually with 5 or 6 wall commands will be time consuming. So for example, if I were to go to the properties section, or to the properties section, and go to the chamfer part over here, I can say that give my point number 2 chamfer of 5,000, 5,000. And this you can give this inside part a chamfer. So sometimes you have this issue of the pipes or the cables cannot turn that easily through sharp corners. So you need to give them some sort of a chamfer for them to turn. So it's very easy to just create this. And the reason why I'm showing all this to you is to remove the fear which most people have of industrial plant concrete modeling. They think it's going to take a lot of time, but from what you're seeing on the screen, it's pretty obvious that with Comosys, you can very quickly go through the modeling of the concrete. Another example which emphasizes the fact that we should model everything and not leave anything out of the 3D model is the excavation. Normally, when people do 3D modeling, what they tend to do is they tend to model the main structure. Then they get the drawings from that. But since they haven't modeled the excavation around the structure, and this excavation a lot of times needs to be shown on the drawings. So what they do is they will continue in AutoCAD and finish off the excavation related information with AutoCAD. But then once they start getting revisions, then they have problems. So in Comosys, we don't recommend that. So let's go to the excavation macro. It asks for the bottom level. So let me just say DZ minus 2,600. If you remember, the bottom level of the foundation was 2,500, but then we added the lean concrete. So that's the bottom level now. And then it basically asks me to go around the perimeter of the structure. So I'll just go around these main points and finish it off. And when I do that, it creates this excavation model. And let me just double click on that and let's increase the size a bit so that it goes, or maybe it needs to be a bit more than that. Yeah, this is better. And let me just rotate this and show you what it's done. It's created this hypothetical model of the excavation, and you can further model this in much more detail. I'm just going to show you what the results would be. Let me go to the drawings, for example. And as you can see in the drawings, that excavation now exists as part of the model. And now we can give levels over here. This is plus minus 0 level. This is minus 2600 and stuff like that. But the point is that because we've modeled it now, we don't need to go to any other software and finish it off over there. We can continue working in Comosys, and that is the basic rule of 3D modeling, that we should not leave anything out. And once again, what I just showed you was probably the simplest model that could have been made. Here is a much more complicated model of excavation, and you can see that the entire excavation, this is multi-level excavation from here to here, then further down, and the slopes have been given. It has all been modeled, and a separate drawing has been created just to show the way the excavation is going to be done at the site. And this feature then becomes extremely useful because not only can you show the details of the concrete, but you can also show the details of the excavation for the people at the site, and you can provide 3D views of the excavation as well, which also makes their job a lot easier. Now, of course, in real life, concrete can be a lot more complex than merely beams and columns and walls and slabs, and you can get very complicated shapes, and that's the beauty of concrete as well. But your modeling programs need to be able to handle those shapes as well. So we have in Comosys all these generic primitives. So we have like boxes or cylinders or cones or pyramids or spheres or toruses or so let me talk about the tapered solid, which is interesting. So let me just go over. All you need to do is basically just select a closed loop, and it'll create a tapered solid for you. And then if you double click on that, you can give it a height, and let's give it a height of 5 meters. And once you enter it, the box is created. But then you can go on and give it a taper of say 11 degrees. And from all sides, it's going to be tapered inwards to 11 degrees. You can give it minus 11 as well, or whatever number. But what you can do more than that is actually say, okay, the first line would be 11 degrees, but after that, I want 20 degrees. So you can get an even more complicated tapered solid if you want. This really makes it quite convenient. But more than that, we have other very interesting features as well. Let me delete this one. And let's go to the extrusion feature. So you can have, for example, retaining walls with this kind of a cross section, or anything else as well. And what you can do is you can create these by using this polygon command, and you can even put holes inside them if you want. But what I'm going to show you over here is that you can use the extrusion feature to select this cross section and select a path. And as you can see, the path is curved. It has chamfers as well. And the moment I do that, retaining wall is created, extruded along that path. And this kind of capability can then be used to model these complex shapes in concrete. And then you can go to the 2D drawings, and it will be unioned, and it will be unioned with all the other beams and columns or whatever you have in your structure, and it will become one monolithic element. Let's do a slightly different example. So maybe you have a ribbed concrete roof in which this is the cross section of the concrete and this is the shape of the roof. Once again, you can go to your extrusion command and you can say, I want this cross section of concrete to go to follow this roof curve, and immediately your ribbed roof can be created, and then you can continue with your beams and columns around it. Like I said, they can clash as well. That's going to be okay. The unioning feature in Comosys doesn't really care about that. It manages to create a monolithic solid on the drawing side. Beyond your extrusion, which is very powerful, like I said, you can even have holes in your cross section and extrude them. But beyond that, you have surfaces of revolution. So, for example, I have this cross section over here, and I want to revolve it around itself 360 degrees. I just go to the surface of revolution command, select that, and select an axis of revolution. And the moment I do that, a surface of revolution is created. So these are very powerful features. Like I said, you have the primitives, you have the tapered solids, but you also have these extrusions and surfaces of revolution. And basically, with these, the sky is the limit, and you can model practically anything under the sun, which your complex project might require. And you can be assured that the drawings will come out very neat and clean according to that. Now let's talk about embedded steel. And the modeling of embedded steel is actually quite important. And sometimes companies don't do that and they prefer to do it in AutoCAD, and that's because they don't have the nice and good tools to do the modeling quickly. But it's very important to have it modeled, because once you have it in there, then you can see any clashes with the rebars and stuff like that, and also the general quality and all your bill of quantities and all those will be much more accurate. And don't take it lightly, because it's not embedded steel is not like 5 or 10 or 15 pieces. You can have projects with hundreds and or thousands of embedded steel placed in your concrete. We just did a project on Comosys recently, in which the number of embedded steel plates was over 100,000. So you can well imagine what kind of pressure that would put on somebody who's doing that kind of stuff with AutoCAD. So how do we actually model embedded steel in Comosys? Well, it's very simple. All you do is you just set your work plane to the surface on which your embedded steel will eventually be located. And then if you've got the location of the embedded steel on that surface, or any snappable point, all you do is just go to your embedded steel command, select the origin, and select an X direction. You could have an inclined direction as well. You can select any direction basically for the X axis. And the moment you do that, you can right click, and your embedded steel will be created immediately on that at that point. Now let's go inside the wall and see what it looks like from the inside. And I've opened the dialog box for the macro which created it. And as you can see, we've got so many options for the anchor bars. These are the ones you're seeing on the screen right now, even for anchor bolt placement, or like I said, the anchor bar placement, or shear keys if you want to place shear keys behind them, or if you want to place rag bolts. So all sorts of options. Let me go back to the anchor bar one. And over here you see that you have the choice of U type, or you can choose an RB type, for example, which is a different. You can change the angles of how they will be sticking out. You can go to the L type, for example, and you can once again give different angles, and you can also choose from these company databases. So, for example, if I choose this one over here, it will be a different one. And if I choose for different materials, you can have different ones. So let me go back to the preferences file folder over here, and go to the anchor bars, for example. And over here you can see that you can set up your company standards for the different types of bars at the back, and for each one you can even have axial capacities of how much tensile forces they can resist, and then that'll be a quick reminder for you when you're designing the embedded steel. So it's very general the way it has been set up. Like I said, you can have all sorts of combinations of your bars, and even after you pull them from your company database, you can still go ahead and modify them for a particular project. So this one has a length of 600 millimeters, but I don't want it that long, so I can modify it there on the fly, and I can create a custom one there and then. And like I said, you can always in Comosys save them away as your company presets. So if I wanted a 16 anchor bolts instead, I would just load that, and my anchor bolts will be prepared. If I wanted 4 anchor bolts, I can give them different names and save them away for later use. If I wanted 4 rag bolts, for example, I could just call in the rag bolt option. If I wanted the set 4 tension bars along with 2 shear keys, I could have that as my embedded steel. So these options are very powerful. You can save hundreds of different types away, or however many you use in your company. And once you have them saved away, which is very easy, not time consuming at all, you can very quickly go through. All you need to do is just select points, like I just showed you. You put your work plane on the wall, or on the slab, or on the inclined wall, or wherever it is that you're working, and you just basically point and shoot, and it's as simple as that. And this is important, the fact that you can model embedded steel so quickly and so easily, because people avoid concrete 3D modeling because of things like this, because they find it too difficult or too time consuming to do modeling of this sort. But with Comosys, All these little things which add up, if you look at the whole picture, they have been put together in a very nice and convenient way. And the moment you're trained to do it, basically it doesn't take much time at all. One thing worth noting is that while we have a lot of control over the objects created by the embedded steel, we have complete control over the way the grid will be set out and the distances between these bars and all that. But whatever bar you choose, so for example, if we have whatever 8, 10 bars over here, they'll all be the same from within the macro. But from outside the macro, you actually have individual control on every one of those bars. So I can just double click on any particular bar, and I say this particular one I want to be of a length of 100. And that particular one will be shorter. And maybe I can do the same to this one as well, or the top two. So I can modify exactly according to what my requirements are, uh, even if the macro doesn't really allow that, because I have individual control over the embedded elements once the macro has been done with them. And of course, like with everything in Comosys, if you were really pushed, you can do manual detailing and you can create any kind of an embedded steel which you wanted. We've done this is a very simple one. I remember doing an embedded steel which looked like a half a building because it was carrying almost 3,000 tons of tension. It was a huge bridge related project. But what I meant to say is that you can basically model anything you want inside Comosys. Now, there's a lot I haven't shown you yet, but we don't have time, so I'll have to just move on. So, for example, I haven't talked about how to create grout or how to create surface slopes if the surface is not if the surface has a slope, for example, how to create water stoppers, how to create individual covers if you needed to, how to create those hundreds of anchor bolt cutouts, which we saw in some of the models, maybe how to create flares. And I mean, there's a lot I haven't shown you, piles, for example, but you get the idea. The point is that you have to complete your model. The grout is important. The surface slope is important. If you don't do that, you will end up finishing your drawings in AutoCAD. You will start off in some 3D software, modeling software, but you'll end up in AutoCAD, and that's where you fall. That's where you make a mistake, and that's why your company never really gets going as far as concrete modeling is concerned, because half the stuff is done in a 3D modeling software, and the other half there might be minor things, but the fact is that they're not minor because whenever there are revisions, you need to go back to the same 2D drawings and AutoCAD. And once you start doing that, like I've mentioned earlier as well, you basically lose the game. It's not the way you're supposed to do 3D modeling. So the reason why I'm just going through these things one by one is to show you how and why Comosys will allow you to actually finish the model even when you have complicated industrial plants which need to be modeled. Now I want to say a few words about general arrangement drawings in Comosys and what kind of things are involved in creating general arrangement drawings. So you saw me create most of this building. I've just copied these floor slabs everywhere. That hardly took a few minutes on all the floors, and I've also created some anchor bolt cutouts on the first floor, just to give it some sort of a variation for the drawings. And now I'm going to go to the drawing side. So I press on this double click on that, go to my drawing manager and open up my general arrangement drawing, in which I have imported the some of the views, not all. I've imported the 3D view. I've imported the ground level, zero level view over there. I've imported the 5,000 millimeter floor level where I have those cutouts, as you can see, the anchor bolt cutouts, and these pits in every slab. And there's a section as well over there. Now, importing these views into the drawing is hardly takes a few minutes, not even that. All you do is you just see the list on the left hand side of all your model views, and you can just right click and say create viewport, and the view will be created. So that's hardly time consuming. What can take some time is the annotation
of these elements and the dimensioning of these elements. And I want to just take you through the steps of doing this because it's not that difficult at all. And if needed, you can always make some manual modifications. So let's go through the dimensioning step first. What you do is you basically select any viewport and you go to this command, which is the linear dimensioning command for that viewport, for a particular viewport, and you just press it. And the moment you do it, the dimensions for the formwork, for the concrete of that viewport are created for you, and they're not even repeated. For example, this one is the same as this one is the same as this one, so it doesn't repeat them again and again in the inside. Had this particular one been a bigger dimension, a bigger foundation, it would have gotten a separate dimension. Now you can do the same on this viewport. Just go there and press the command again. You can go to this section over here and press the command again, and your dimensions will be created. Now what you can also do is select individual elements like these anchor bolt cutouts and press the same command again, and they will be dimensioned there and then in front of you. Another thing which you can do is press the level indicators symbol over here. So just select the viewport and press level indicator, and your level indicators will be created on each wherever the level is changing. Wherever you have a new level, you will get your level indicators, and then you can move them around if you wish to. So by doing that, or for example, if you do that in the plan view, for example, you will get level indicators like this in the plan view, and you can put them anywhere you want. If there are different levels, then all of them will be dimensioned. So dimensioning, as you can see, is pretty fast, and you can always go and manually modify it if you want, but it's pretty clean as well. The next thing which you want on these drawings is the annotation. So you want to see what each the assembly mark of each beam and column and slab and this and that in the sections and in the plan views, etc. And once again, you can do that individually. You can select pieces individually, and you can mark them. And there are very specialized commands for creating all sorts of annotations. But you can also do that pretty quickly. But once again, like we did in the dimensioning of the viewports, we can select the viewport and we can auto annotate the viewport as well. So when I do that, for example, in a few minutes, it's going to find places for the annotations. So it has found places for the slabs and for the pits and for the beams, for the columns. It has found places which are not clashing with each other. And as you can see, it's pretty clean. There's not much to be modified over there. I can come to this side and select this one and press the same auto viewport button again. And once again, my beams and my columns and my slabs are all annotated. Obviously, this will depend on my numbering options and the way and my selection as well, and my settings. Right now, I haven't really checked the settings, but what I'm trying to show you basically is that you just select the viewport and you select auto annotate, and you select the viewport and you select auto dimension, and you get reasonable results because these are general arrangement drawings. They're not assembly drawings, but you get a lot of the dimensions which you will need, and then you can finalize them after if you see something missing, or if you see something needs to be done in a different way. Now you might be thinking that I've showed you a fairly simple building and gone through the commands, but I've promised you that any kind of an industrial structure can be done. So here is a little example of not that complicated, but reasonably complicated structure, where this is a water intake structure, which has been modeled entirely with the commands that I've showed you. As you can see, all the holes in the slabs and the depressions and the anchor bolt cutouts and the covers. And over here, for example, we have a very unique feature in which this part of the concrete, let me just hide this. So you can see that this huge water intake, a water pipe was there, and this pipe itself became the formwork for the concrete poured around it. And let me hide yeah, so you can see on the screen that very complicated things can be done with COMOSYS very easily. What you see on the screen was hardly took a few days to do as far as the concrete is concerned. And all the commands which I've just showed you went into the detailing of what you're seeing on the screen right now. And once you have the model ready, you can immediately go to the drawings and create your plans and your sections and 3D drawings and whatnot. And from once you're done with that, then you can continue with the rebar detailing. So here is another example of complicated structures. These are examples of the hundreds and thousands of embedded steel which I was talking about. This is a cement plant, and here we see a combination of steel and concrete together. So, I mean, it's pretty clear that Comosys is not limited to the kind of building classical just beams and columns type of structures that we typically show in the webinars just because of time constraints. But anything of this sort, any complicated structure, can easily be modeled within Comosys. Here we are inside the concrete, and as you can see, the rebars have been modeled in 3D, and there's a lot of rebar in there. This is a huge structure, but it's so easily being done, and you can see the beautiful results on the screen. And once you get used to this kind of modeling, and once you get used to 3D modeling of rebars and concrete, you will not look back. You will not want to go back to the classical 2D AutoCAD methods. How about this for complexity? This is the foundation of a continuous casting machine, which is used in steel plants. And this is a huge machine, and all these are points where the machine is sitting on the concrete, and it has to be modeled extremely carefully. As you can see, there are lots of these little stubs coming out, anchor bolt holes, other types of depressions, changes in geometry, all these drainage channels, and what you're seeing is one of the most complicated types of equipment foundations you will ever do. And this was done entirely in Comosys and in record time, much faster than the AutoCAD statistics which we had from the past. And this is truly something to think about. If you can model something like this and put rebar in it and take plans and take sections and get your material lists and your material takeoffs, everything from this model, then there's practically nothing which you can't do. This should suffice to um, to basically convince anyone that whatever they're doing in concrete, however difficult of a structure they're doing in concrete, they should not worry and they should immediately switch to 3D modeling.
And you might be thinking that show me the drawings which you have extracted from those complicated 3D models. So what you see on the screen is Comosys once again. These are drawings taken from those models, and you can see the quality of the drawings. They're very clean, and they can easily depict or show or put in the form of a 2D drawing any complicated structure which you can model inside Comosys. Here is a sectional view from the same structure which we just saw. And as you can see, it's very clean. It's very, the section has been taken properly, and you can obviously modify the points from which you want to take the sections. And once you have the section, you can just go over it extremely quickly with some automatic dimensioning commands, which I will show as well. Here is another section where you can see those inclined drains as well, extending in the Z direction. And here we see them with a shorter depth, with a lesser depth, so we can just see a part of it. As you can see, these are all automatic sections taken from the model, and they really bring down your work. Otherwise, for each section, if you're doing it in AutoCAD, you would have to work half a day to create these sections, and they would still not be accurate. But once you have the 3D model, then the generation of plans and sections is really very easy. Here we see another section from a different area in the in that CCM machine foundation. You can see the quality of the drawing.
And this will give you an idea that what we are talking about is not just those simple buildings with beams and columns in which you can produce sections and plans very easily. These are really complicated structures, and they really bring down your man hours tremendously. To make the people at the site understand the concrete better, you can even have 3D sections. You can create sectional views from the 3D model and show them to the people at the site, and they will understand exactly how they need to pour the concrete. Here you see another 3D section. And over here you see several sections taken in the same drawing. Over here you see those hundreds of anchor bolt cutouts, which are very common in equipment foundations, and they've been dimensioned and very cleanly, and you can see how a beautiful drawing like this can really improve your quality, your brand name, and also along with the 3D images and the 3D sections which I just showed you, can really take the level of your company several notches above.
Now, let's move on to rebars. It's interesting how well established the steel industry is in 3D modeling and how lagging and far behind the concrete and rebar modeling industries are. Now, part of it probably has to do with the fact that steel softwares were developed earlier and got a head start. But as things stand today, there is really no excuse left for the concrete industry to stay behind. My purpose in this part of the webinar is to create some confidence in those who haven't stepped into the world of 3D rebar modeling yet. Those who have will hopefully also like what I will show, but I'm more focused on those who haven't. I hope that owners of businesses will watch this webinar later and will start believing their companies can actually make some money out of it if they switch today. There will be a few hiccups, there always are, but that's the job of visionaries. They are the ones who keep pushing despite all the naysayers and eventually take everyone with them to a higher level. Change will need to come from the top. Change will need to come from the visionaries. Now let's start modeling rebar together. Watch me show you how easy it can be. I'm a firm believer that the best modelers are the ones who can work fast even without macros. Obviously not as fast as with macros, but fast enough to get the work done faster than the classical 2D AutoCAD techniques. So follow me and imagine you are doing it. When you start believing is when it will happen for you. It's a bit like the Matrix. So let's start with the absolute basics. Here on the screen you see a small slab. It's pretty simple, and we want to put some rebar in this slab. Now over here in the concrete menu we have this rebar command over here, one to create a rebar group and one to create a single rebar. Let's go with the rebar group, and once we do that it asks us to select a parent object, which is the slab. I select that, then it asks for the shape of the rebar. So I'm going to put a rebar like that. So I'm going to say this point, basically I'm using the concrete itself as the snappable element, this point and this point over here. And then once I'm done with the shape of the rebar, I right click. So the rebar shape was like this, like this, like this. And now it's asking me for the range where it will go. So I show at this point and I show at the other point of the slab. And then it asks me for a Y direction, but I don't need to enter that. So I just right click. And the moment I do that, immediately rebars are created on the screen. Now, at the moment, there is no clear cover, as you can see on the screen. So all I need to do is just double click on the bar. And in this clear cover section, if I can give it a clear cover of 50 millimeters, for example, and immediately you see that my rebar has been provided with a clear cover of 50 millimeters. Right now, the ends are still touching the bottom of the slab, and I don't want that.
So for that, I just double click again and give it a start offset of 50 millimeters and an end offset of 50 millimeters again. And when I press OK, my start offset and my end offset have also been pulled back. Looking at it from the plan view, I see that the range also needs to be pulled back. So I double click on the bar and here I have my range pullback. So I give it the same 50 millimeters. And now my range is also pulled back with the clear cover of 50 millimeters on both sides. By the way, you can enter more than one number in this range section. So I can give it a number of 100 millimeters for the start and 50 for the end. And in that case, my start will have a pullback of 100 millimeters while the end will remain at 50. The same kind of thing is possible for the clear cover as well. So if I were to open that and say, instead of saying 50, if I said 150, 150, and then 50 again, what that would mean is that my first leg will be pulled back 50 millimeters, the second leg will be pulled back 150, and the third leg back to 50. I can do the same thing with the minus sign as well. If I put in minus 150 over there, my second leg will be pulled out of the concrete. Now, when I select a rebar, this little gray button appears over here. And instead of double clicking on it and opening up the entire dialog box, which is complicated, what I can do is I can select the rebar and just press on this gray button which appears. And I get this little box over there, which gives me the most frequently used options. So for example, I can open up the hooks at the start or the hooks at the end, turn them back on and off. Obviously, the parameters will depend whatever has been set inside. I can go in and change the spacing. I just press enter and now the spacing instead of 250 is 500 millimeters. I can change the type of the rebar. It can be different types. It can be top main, top secondary, bottom main, bottom secondary, longitudinal, intermediate. All sorts of options are available over here, and you can choose them according to your needs. So that wasn't that difficult, was it? Congratulations, you've just become an official 3D rebar modeler. Well, we know life's not that simple, so let's make it a little more complicated. If I were to double click on this bar over here, you see at the top right corner, there's this option of linear tapered, straight, general. So it was created as a straight bar when I initially did this. Now, what I can do is I can double click on that and convert it from a straight bar to a linear tapered bar. But before I do that, let me show you something on the screen. When you initially created it, when you select any bar, you see this initial bar path over here. This is the bar path which is going to continue along the range. There's only one bar path. But if I were to double click on it and convert it from straight to linear taper, then a second bar path appears at the end, this blue one. So there's one at the beginning and one at the end. Now, what can I do with this? What I can do with it is I can select the segments of any one of these. So let's select this one and give it a move, let's say, of a few thousand millimeters. And immediately what you see on the screen is that your bar has become a tapered bar from the start to the end. And that was very convenient. I can do that with the edge, with the segment at the other end as well. I can go and I can make it move inwards as well. It's a linear tapered bar now, but there's more. What I can do is I can select these, and at the end path, instead of selecting the whole segment, I can select this bottom point only, or I can select it like that. I'm sorry. Yes, like that. And I can actually make it go up if I wanted to, say 50 millimeters. And when I do that, what's happening is that the end bar is moving, but the first bar is still there, and there's linear interpolation between the 2 points. I can do the same at the other side as well. I can select this one, and I can move it, say, 550 up, or let's make it 1000 up, and see what happens. And now we've got a strange situation in which it starts off like that, and it tapers up in that direction.
So we've got a lot of control in this, if you notice. The moment I select them, I've got a starting path and I've got an ending path. And by moving those ending path segments or points, I can basically create a very complicated bar in a few seconds. But life can be even more complicated. So let's double click on the bar again. And from linear tapered, let's convert it into a circular taper and press OK. Now, in this case, you see you have three paths to play with. One at the beginning, one at the middle, and one at the end. And just like I did with the linear taper by moving the path segments, what if I move this segment once again, some number like that? And now what you see is that instead of a linear taper, we're getting a circular variation in that on the left hand side, depending on what segment you choose. And similarly, I can do the same for the other side as well. I can press the same buttons and I can get my circularly tapered bars. Well, congratulations again. Now you're an advanced 3D rebar modeler. You want to become even more advanced? Let's select the middle one and select the stop segment for a change and move it up, for example. What do we have here? Well, that's interesting. You've got a variation circular like this and circular like that. And I mean, you can see where I'm trying to get with this, that you've got a lot of control and very easy manipulation methods, just playing with those handles, playing with those segments to create very, very complicated rebar shapes. Let's play around with it a bit more. Let's select the rebars. And let's say you had forgotten a point in the original definition. If you remember, I had defined the bar like that. But what if you had forgotten a point right in the beginning? Well, what you can do is you can select this endpoint. You can zoom in and select this one as well with pressing Control, and you can zoom in and press this one as well. And after having selected all three, if you could just say add point, then a vertex is added at the beginning, at the start point, and now you have an additional definition point in your path. You can do the same by, for example, what you could do is you could add a midpoint over here, and you can say plus, and you could give it, say, a Z direction of 1000, move. And once you do that, you've inserted even more points. So you can see very clearly on the screen what's happening, and you're becoming an even more advanced user as I speak. Now, just like we could play with the path points whatever way we wanted to, we can also play with the range points. So if I were to select this bar, we see that this range line appears over here. And there's a start of the range and there's the end of the range. And the start and the end can be selected. So I've selected the end of the range. And what I can do is I can use these two buttons over here to move the range. So if I press this one, I'm moving it forward. If you notice, it's going forward by 1 meter. And it's basically the same point is moving upward. So let me move it a bit more. Now bring it back. And let me do the same thing again now, but with the other command. Let me select the end. And instead of using this one, I'll use this range extension. And when I use this one, then instead of this point moving upward, it will move along this taper. So let me do that. And now you can see that it is moving along that taper. And both of them can be required depending on what your needs are. Let's play a bit more with the rebars. So let me select this one over here and select this segment. And over here, I have the option of breaking this segment. So up till now, we've moved the points or the edges around, but I'm going to actually break the path. So I go to the break path and it asks me for a point where I want to break it. So I could just select the midpoint over here, for example. And when I do that, immediately the bars are divided into 2 bars. So there's one going from here to here and the other one going the rest of the way. And now what I can do is I can just move this one, for example, say 20 millimeters in the Y direction. And then what I can do is I can select this endpoint and give it a move of, say, minus 1000 in the Y direction. And there I've created a little splice at that point. Now, just like I could break the path by selecting a segment and then showing it any point, I can actually also break the range. So this bar was placed from from this point to this point as a single ID, what I can do is I can just zoom in and just click on any one of these little plus signs. And when I do that, this little option appears and I can tell it to break at that point. What I will do is it will break the range from here to here and then from there to the end. And now what I can do is obviously double click on the other part, for example, convert it into a linear taper, and then move that part inside maybe. So now I've got this different thing going straight and then moving in. And with a few clicks, I've managed to follow whatever geometry I might have on the in my project. Let's do some more range modifications. So with rebars, you're usually, when you're looking at rebars from a sectional view, you're either seeing lines or you're seeing dots. This is the most common way of looking at rebars, either lines and dots. And when you're looking at dots, you might want to move them so that, for example, you might want to move these dots right up to this point where they come to this end of this segment just before the radius starts turning. And you want to do that in a precise way. So all you do is you select that, you select the range handle, and you select this button over here, and you just show it this segment. And the moment you do that, those dots are moved right to the point where they fit snugly just before the radius starts. Sometimes the requirement might be different. You might want these dots to move in this direction right up to the point where they're just beyond this vertical green bar. And that could be another requirement which you might have. So what you do is you basically select the bar again, and you select this range button, you press this, and then you select this segment this time, and you show it the side where you want it to go. And the bar is immediately placed to the other side of the rebar. So here is another interesting situation. I have a bar going like that, but I want to pull it back inside the concrete along this side, which has been cut at a tapered angle. So all I do is I select the bars, I select this endpoint, and I say, give me an extra point. It gives me an extra point in the wrong direction, vertically upwards. So what I do is I select my work plane to a surface, and I select this back surface. So I have my positive y direction going like that. So I then select my bar again, select the point, and I say I want to move it, and I say select distance. I zoom in, I select this point, and then I come over this point, and I say I want to offset this point even further by dy minus 1000. And when I do that, those numbers are filled up, and I can just say move, and my bar has been moved along this line from a vertical position along that line. So that was extremely easy to do. Let me just go from the side and show it to you from side what the final result is. As you can see, this bar which had turned up has now come back along this line a distance of 1000, just the way I wanted. Now, let's say you have rebars going around the sides of a slab, or it could be some other example as well. And later on, the slab was given a chamfer. So let's give it the chamfer. Let's give that plate a chamfer of say 3000 millimeters, and the plate was modified like that. And your rebars obviously came out like that. So you can give the same chamfer to the rebars as well by selecting these definition points, and you can go to your rebar to the chamfer option, and you have two types of chamfers available, type 3 and type 4. In this case, since the plate has type 3 chamfer, we can give it the same one. And if we just press apply, then the rebar can be chamfered. And if you look at it from the plan view, you can see that now it's once again following the shape of the slab. Have I managed to relax you a little? Have I succeeded in giving you the confidence that you can do this? Giving you the confidence that you don't necessarily have to continue with 2D AutoCAD detailing and actually jump into 3D? You've seen how quickly I've been doing this, how fast I've been doing this, and I'm basically using nothing but manual modification commands. What I want you to feel, what I want you to think is that doing it even without macros is actually faster than doing it in AutoCAD. And if you do have macros, then you can actually go orders of magnitude faster. If you think about it, even the complicated examples are just more of the same. It's just a lot more of what we've done, but it's the same thing repeating itself.
You keep creating the rebars, you keep modifying the paths, you keep adding new vertices, you keep moving the segments, you keep breaking the path. Basically, it's just more of what we did. You convert it into a linear one or a tapered one or a circular one, and there you go. So what we've shown already, what we've seen already, is quite enough to do even these complicated things which you're seeing on the screen. They're not very different from what we've done. They just look like a jungle, and that's scary. But then I'll talk about how you can get rid of that jungle and make it a bit cleaner for yourself as well. But the point is, rebar detailing is not difficult. You can do it. You can do it better than the people are doing their things in the steel industry. So what I want you to go, the way I want you to leave this webinar today, hopefully, is with a renewed sense of confidence that you can do 3D rebar modeling.
I think you're still not convinced. So I'll probably need to show you a bit more. So let's move on. I'm going to show you the sectional reinforcement command, which is a very powerful command which you can use for a lot of different cases. So I'm going to start with the simpler cases and move on to the more complicated ones. So let me go in and select the command. It asks for any object. So I can select this column, for example. Then it asks for a point. So let me just select any point. Let me press the control key and select any point on that column. And the moment I do that, it takes a cross section of that selected element at that point. Now, each one of this is a potential rebar, or all of them put together, or any combination can also be rebars. So if I want all of them, so let's say I want to make a stirrup, which will go all around the column. I can just leave everything selected right that and right click. And when I do that, it realizes that this is a closed loop. So it asks me for the point where you want the hook to be. So let me select this point. And then it says, okay, where do you want this to end? So I go up and I go towards the end of the column and I press my control key and I press enter again. And I want my last stirrup to be over here. And when I say right click, immediately with the defaults, obviously, the stirrups are created from that point to that point. Let's use the command again to understand it better. Let me go back to the sectional reinforcement, select the column, select a point, like I said, anywhere which is snappable. And now this time, instead of right clicking to tell it to make the complete loop, let me go and select this one, and this one. I don't want to do the complete loop. I just want to do these three sides of the loop, and then right click. And this time it doesn't ask me for the point where the hook will be because it's not a closed loop. It just asks me for the final point where I want this bar to end. And this time, as you can see, it brings only the partial bar. And when I do right click, immediately my bars are created with that shape, which was taken from that cross section. Now let's use it on an inclined column. So let's go back into the command, select the column, select a point near the base. It creates the inclined stirrup. I right click to show it where the hook will be. Then it asks for the final point. So I choose this one and I press right click and my stirrups are created at the incline like that. But what if I did not want them to be inclined? What if I did not want the stirrups to be like this, but I wanted them to go like that along the global Z direction, not inclined along with the column? What would I do in that case? So let me just press Control Z to undo. And I basically go back in there, back to the same command, go back to my sectional reinforcement, select the column. But as I'm selecting this point, I press the 3 key. 1 is for X, 2 is for Y, and 3 is for Z. And 3 would tell it that I want the direction to be along the 3 axis, which is the Z global or the current work plane Z axis. So if I press 3 while selecting this point, it's going to take a cross section, but the outer unit normal of that cross section will be in the 3 direction of the local work plane. So I'm fine with that. Let me right click, show the point where the hook will be, go back in there, select this point while keeping 3 pressed once again, right click, and this time it asks for another section point. I don't want that. And this time, as you can see, now it has created the stirrups once again, but this time they are parallel to the ground. Now, in the examples I've shown so far, I have taken a section at 2 points and the bars have gone from point 1 to point 2, but the shape of the bar has remained constant, whatever the direction may be. But what if we had a tapered column like this? In that case, what would happen? So if I go to my sectional command once again, select my tapered column, select the first point by pressing 3 because I want them in the global direction, right click to accept all, and let's say put the hook at this point, and then I go up and select this point, press 3 and right click again. Now as you can see, that because of the column has been tapered and because the sections were different at this point and at this point, it has done an interpolation, a linear interpolation from that point to that point. And I've created stirrups which vary in a tapered way. Let's move on to a slightly more complicated cross section, like maybe a retaining wall. And once again, go to my sectional command, select that parent, go and select any point. On that surface, it immediately gives me the cross section at that point. Let's say I only want this bottom bar and I don't want the whole cross section. I select the bottom bar and I press right click. And then I have to go to another point at the end and it brings me the same bar and I just say right click to create those bars. Now we've created this single bar at the base of this retaining wall. What can we do with it? Let's double click on that and see that we have some embedment options for the start and some embedment options for the end. So if I say put the end to the nearest surface and say apply, this little bar then gets embedded into the retaining wall up till what point? Up till the nearest point where it hits the concrete again. So it will automatically calculate how much I need to go. In this case, it's almost 1 meter. So when I choose this to nearest surface option, it will basically move in that direction. I can also say by embedment length. And what that is, I can give a multiple of the diameter. In this case, the diameter is 10 millimeters. So if I say 30 phi and say apply, it's going to turn up and go about 300 millimeters, depending if that is your embedment length. So if I increase this one to 60 phi, for example, the bar will be moved further. What if I make it 120 phi? What's going to happen then? Is it going to realize the shape of the retaining wall? As you can see, it went up and it hit a wall and then it had to turn, and it turned inside towards inside the concrete. If I make it 200 phi, it's going to go further. What if I make it 450 phi? Well, it's going to go all the way and it's going to turn again. So this is an amazing feature in which you can create a single bar inside some concrete and then ask it, give it any embedment length, and it's basically going to start turning inside that concrete. Let's put it back to none. What I can also do is I can give it custom angles. So if I give it a custom angle, then now this has a custom angle of 90 and 500. When I apply that, it says what it tells it is to turn 90 degrees and go 500 millimeters. But with this one, I'm not restricted to staying in the concrete. I can just say another 90 degrees, and this time I can go another 500. Let's see what happens if I do that. So it turns outside. I can bring it back in if I want with a minus in there. And then I can actually turn it, if I say 45 degrees and another 500, I can make it turn upwards, or if I do a minus 45 over there, I can make it turn downwards. So with this kind of complete control over the end conditions, I can do the same thing for the other end as well by using these variables over here. I can basically create any sort of bar I want after having created just one base bar. Now, what if instead of creating the bar at the base of this retaining wall, I had initially created a bar like this by selecting these two segments and then let it run across the retaining wall? If I double clicked on that, so this in the first one there was a single bar. Now I've created the initial bar which looks like this. Now in this case, if I were to give it an embedment length of 30 phi at this point, it's gonna turn into the concrete at that angle. If I give it to nearest surface for the other end, it's going to go and hit the bottom of the concrete. If I give it a bigger embedment length of 120 phi, it's going to turn into the concrete once again. So as you can see, this is a very powerful command, which not only allows you to use the cross section to create your bar, but then also extend the endpoints to whatever embedment lengths which you might be needing. Now let's make you a really advanced 3D rebar modeler. So you can go back home with the certificate. So let's go back to my sectional reinforcement command. Select this strange looking structure. It could be anything. But the thing is that these are complicated circular paths which have been created. And let me select that, and let me take a section by pressing the 3 buttons, so it goes in the positive Z direction. So I'll accept the complete loop and give this point to be the hook point. Then I go to somewhere near the top, press 3, press that, accept it, right click, and my rebars are created on the screen. And as you know, what this command does is it takes the first cross section and it takes the last cross section, and it does a linear interpolation between the two. But what I can do now is I can double click on this, and inside, if you see over here, there's an option of take a section at every spacing, which means that at every bar spacing, I'm telling it to recalculate the section rather than doing a linear interpolation. So if I press that and I press OK, then lo and behold, there's magic on the screen. It just takes a section at every rebar from that complicated shape, whatever it may be, and it creates this horrible looking rebar, which I don't recommend. But what you would do in a realistic situation like this would be to actually have separate rebars on all 4 sides, and there would be like U-shaped bars on all sides. But just to show you the power of the command, I wanted to take you through this so that you can get your certificate of advanced rebar modeler. One final word about the sectional reinforcement command. Up till now we've been using it for one single object. We created a few objects, but let's say you've got multiple objects on your screen. This could be for whatever reason that's the way you've modeled your structure, and you want to actually create a section from all of them. So what you can do is you can select all of them. They can be 2, they can be 3, they can be 4, any number you want. And before you enter the command, and then when you enter the command, it will union them temporarily and ask you for a point. So let me select a point over there, and it will create a cross section from the unioned shape of those n objects. So let me go ahead and select these bars, for example, right, like that. Right click, it asks me for the final point, so I have to select the formwork object again for the final point. Right, let's say I show it this point, and I say right click, and immediately my bars are created from the section of that unioned object. So you have complete control over what you can do. You can even union objects together to create your rebars, and that's really better. Now let me show you the segment reinforcement command, which is also very useful. What it does is all you need to do is select a segment of any bar. It doesn't have to be a closed loop or a stirrup or anything, but all you do is you basically select a segment and right click, and immediately along the entire segment these segment bars are created. And you can when you double click on them, you can change the count. For example, I can make them 5 bars. I can make them, if I make them 5 bars, what I can do is I can say, okay, put 5 bars, but don't put the first and the last. So what that will do is it'll put the middle 3 and leave out the ones at the corners. If I leave that as it is, then all 5 will be placed. So let me put 3 bars over there, and I can do that very easily. I can use the same command on the bottom leg as well. Right click, and immediately the segment rebars are created. And in this way, you can very easily create your beams and columns manually, even if you needed to. Now, another way to work with this is to, let me undo that, is to go to your segment reinforcement command, select a leg, but then don't right click, but select point 1 and then select point 2. So it will then create those segment rebars between those points, along with the offsets, of course. You have the additional option of having these offsets to the start and the end. So you can very easily use that those offsets, and it will basically do the creation for you. Now, let's move on to the cranking of straight bars, for example. So we have this command for cranking over here. All you need to do is just select the command, and select any straight bar, and immediately it will be cranked in a certain direction. If you don't like the direction, what you can do is you can select the points and just give them a move of, say, minus 800, whatever direction which is suitable for you. Or if that's too much, maybe you can bring them back up a bit. But very easily you can move it around and create cranks in the bar as shown. And initially you can go in and actually modify the actual numbers of what you want these distances to be and the angles to be as well. Now let's do an extrusion example. So what I've done is I've created this little this cross section over here with double holes inside it, and I've extruded that along a curved path. So you can think of it maybe like a bridge. And what I've done is then I've, using the sectional command, I've created this stop bar inside it. I mean, we can create many bars with the section command around that and do the whole thing in one go as well. But I've created just one, and I have this path of the bridge over there as well. This is the curved path which I used for extrusion of the bridge. So all I'm going to do is now go to my extrude rebar command. It asks me to select a rebar. I'm selecting this one. Then it asks me to select the parametric path, which is this one. And then it asks me to select the rebar parent, which is this bridge deck. And when I do that, immediately my rebar is extruded along the length of that bridge. So imagine if you were doing this whole bridge cross section, all you would do is just quickly create, using the sectional reinforcement, all the sides, give them a few modifications with their embedment lengths, and use the extrusion path to create the entire rebar in that cross section. It's going to be that simple. Now here is a circular water tank, and one thing you might be thinking of is how do I go about putting the circumferential rebars around such objects? There would be some over here, there would be some over here, and all the way down into the slab. So to do that, what we can do is we can use our, once again, we had the segment reinforcement which went linearly, but then we also have a segment reinforcement which goes in a radial way or in a circumferential way. So if we do that, it asks me to select a segment. I can select this segment, I can select this segment, or whatever segment of that bar. So let me select this one, and then it asks me for a start point for the rotation axis. So this point needs to be basically the middle of this cylinder, let's call it. So let's select this point, and I need a vertical point above that. So I'm just going to hover over that and say DZ 1000. I don't need to create the points. And when I do that, as you can see on the screen, immediately, immediately what happens is that my rebars are created outside of that segment. That could be the default. I can reverse the direction to take it inside the segment now. And then what I can do is, instead of a count of 5, I could give them a spacing of 200. So now my bars are spaced at 200. Now, as you can see, they're going all around the tank. Just inside, I can give this another offset, so I can double click on that and give it a start offset of, say, 20 millimeters and a end offset of 20 millimeters. What that will do is that since we selected this segment, it's going to give it an offset of 20 millimeters from the start of the offset. Let's give it a bigger one to make it more clear. Let's make it 200 and 200 so that it's a lot clearer. So from the start of the segment, 200 down, and from the end of the segment over here, it's 200 up, and we have our circumferential bars. But we're not going to in real life, we don't put bars going all around. What we do is we start off from a certain angle, and we'll go 12 meters, and then we'll have a splice. So what we have, the option we have over here is I can just double click on that, and I can, for the start offset and the end offset, I can say start from an angle of 0, but end at an arc length of 12 meters. So I can have start from an angle of 0 and end at an angle of, say, angle of 45 degrees. If I do that, then it's going to start at an angle of 0 and end at 45 degrees. But if you notice over here, every bar is of a different length. These bars, since they're at at the top and the radius is smaller, so their length will be shorter. And since at this point the radius from the center gets much bigger, so their length will. So all of these bars will have a different part position or some variable length, and we might not want that. We might want them all to be the same length. So what we can do is, instead of using the angle option, we can use the arc length option. And when we do that, then we are telling it to put a bar of 12 meters starting from angle 0. Now all these bars will end at different points, but they'll all be of a length of 12 meters. And then you can repeatedly use the same command to start from 0, 12 meters. And then the next bar you can put is start from 12, 12 rather than 12 meters, maybe 11 meters. So it starts 1 meter short of that. So there's a splice, and start at 11 meters and end at, say, 23 meters from the 0 angle. So you can go all around and come back to the start and very easily create your spliced rebars in this manner. Now let's repeat the same command which we did for this inclined segment for this vertical segment over here. And all we need to do, like I said, is select the segment, and then it asks us for that center of the cylinder, and I can just select that point and press enter and say DZ1000. And when I do that, immediately you can see that my circumferential bars for this side segment have been created, and this time they're different. I have used the same from angle 0, 12 meters, but since this segment is vertical, they all end at the same point, because all along the segment the radius from the center is the same. Then I can continue using it on this segment, and I can even use it on the bottom segment, which is basically the closed slab. And what you will get is the circumferential rebars on the slab. So by this simple command of circumferential rebars, I can quickly model the rebars in this tank. I mean, you can probably believe now that it is doable in a couple of hours maximum. So now coming back to the original point, which we have discussed so many times, the purpose of this webinar for me is to relieve your fears of 3D modeling of rebars, to ingrain in your minds that it's not difficult, it's not time consuming, even without macros. Even if you don't have, I'm going to show you the macros in a second. I know you all want me to get to that point as well. But believe me, when you're dealing with prestigious projects, when you're dealing with high-end projects, and I'm sure many of you are, you will be doing manual detailing as well, because all those twisted and curved and ridiculous shapes which you will come up with, or those strange looking geometries which the architects will present to you, they will not have macros necessarily to get you through them. But what I've tried to show you today is that even without macros, you can do the job pretty easily.
Now, if we think about it, in reinforced concrete, it is usually the surfaces which need to be reinforced with steel. So this is a slab, and there's a top surface of the slab, and there's a bottom surface of the slab as well. It's got 3 holes in it right now, and this is not a very difficult slab. But the point is that when we think of the top surface, for example, we see that many different positions, part marks, or rebar marks. So for example, if we were to take this direction, we will have a rebar over here in this region. Then we will have a rebar in this region, another one in this region, then another one over here. Then there will be another one like that, and then another one in this region and region. So basically going from left to right, there will probably be about 10, 12 different marks. Now the commands which I've shown you, like sectional reinforcement or direct bar entry and things like that, you will need to create each bar. So you need to create, for example, this bar by taking a cross section over there, then one over here, then another one over here. So you will need to do that sectional reinforcement command maybe 10, 12 times to arrive at a solution for the y direction of this top surface. Now, the same is true for the X direction. You will have a rebar along this line, then one between this area, then another one between this area, one at the back, and so it's going to be a little time consuming. But what if I showed you a command which would take the entire surface into consideration and all the holes in it into consideration, and find all the possible areas where reinforcement needs to be placed, and actually place that? So let's go to the surface reinforcement macro, and we select the slab, we right click, and then we right click again so that we don't want to select any other elements, and I'll talk about that in a second. But it then asks you for a surface. So you can select the top surface, or you can press Control to press the bottom surface, or you can select the side surfaces. Basically, any surface you can select. So let's select the top surface over here. It then asks for a direction of the bar. So let's give it the X direction first as the main direction. When I do that, immediately on the screen, you have this beautiful result. Now, the good thing about the way it has placed these rebars is that if you notice, it started off with a clear cover from over here. It's gone on, but then it has realized that there's a hole over there. And so one bar needs to be placed just before that at a distance of the clear cover from that edge of the hole. And then from the other side, where the hole finishes, once again, a rebar is needed at a distance of one clear cover from that point. And similarly, when you get to the end, the same thing is there. And then for the other region, it hasn't started immediately over here because there's no need, and there's a spacing distance between the two. And once again, over here, we see that the clear cover has been maintained as well as over here and over here and everywhere. So this is important because what normally programs do is they will start off with a clear cover and then just put equally some spacing wherever they may go. So it'll start from here and end over here. The first and the last bars will be okay, but this bar might not be at exact clear cover, but it might be somewhere over here. And this bar might be maybe somewhere over here, and there could be no bar with a clear cover. So what the user then needs to do is he needs to go and individually check each and every one of these and make slight modifications in their ranges so that to ensure that the clear cover is maintained around all the holes. But in Comosys, what the surface macro does is it sorts that out for you very conveniently. Another advantage of the surface macro is that while it places all these dozens of different rebar marks in one go, you still maintain individual control over each and every one of them. So for example, each one of them is actually a separate, if I press M and enter, you have separate control over each one of them. So what you can do, for example, is you can change the spacing of only this particular part and the spacing will be modified. Another thing you can do is you can change the end conditions, for example. So you can go in there and say, I don't want the embedment at the starting point. So when you do that, the embedment is released. So while you're doing the entire thing in one go, you still maintain individual control over all the individual rebar positions. Another huge advantage of the surface macro is that, like a while ago, I just placed the rebars in this direction. But you can ask the surface macro to place the rebars both in the X and Y directions. So let me do that and select the top surface and give it the main direction. So this is the main direction. And the moment I do that, the rebars are placed in both the main as well as the secondary directions. It finds the secondary direction automatically perpendicular to the main direction. But now you have dozens of rebars, each separate. So there's ones in the Y direction, ones in the X direction, and you have complete control over each individual one over there. This really facilitates your work, and if I want, I can immediately go back and reapply it to the bottom surface as well, for example. So I can select the bottom surface and tell it that my main direction is still the same, like this one. And now my bottom rebars are also placed in a single go. So in a few clicks, I have managed to create maybe 100 different part positions, which are all properly placed according to the clear covers around the holes. And I can then even modify them further if I wanted. Sometimes when there is congestion or embedment is difficult for whatever reasons, we use mechanical couplers to do the same job. And in Comosys, it's extremely easy to put couplers at the ends of rebar. So all you need to do is just select the end of the rebar, and the coupler will be created according to the manufacturer's standards. So what you can do is you just select, like I said, the end, and your couplers will be created. And it's not that you can only create circular couplers. Inside the macro, you have options to create rectangular ones, for example. So let's do that. Or what you also have the option is to actually call a shape database in which you will be asked for a manufacturer and a family and the item, the particular coupler which you have in your standards, and you can all feed them into Comosys through the shape editor. And once you do that, they will be recalled and you will create very complicated couplers as well, as far as the geometry is concerned. Sometimes, once again, because of congestion, we need to put two bars together as a bundle. So after having created your surface bars, what you can do is you can just go to convert a rebar to double rebars and just select on the bar and right click, and immediately each one of them will be bundled with another one of the same. And that's very convenient to quickly do that. Another option is available to actually convert it into three bars. So what you can do is select the bar, right click, and now you've got three bundled together. Now, what the surface macro does for you is very intelligently and very quickly, it finds all the regions on a surface and places the bars beautifully, taking into consideration the clear covers at every hole for you with a few clicks. But what it doesn't do for you is the fact that some of these bars may be longer than, for example, 12 meters. So this one is 23.9 meters, for example. So these bars then need to be spliced after that. And you can do that with a multiple selection as well. But I'm just going to take you. So all you do is basically you go to the splice macro and you have your splice operation rather. We have the system of operations on top of surface macro, which even if the surface macro runs again, the operations are also modified every time you do that. So you can have your spacing input. So you can say at every 8 meters, I want to splice. You can place extra bars. You can shift the bars. I mean, I'm not going to go into the details of this. This is it's very detailed and lots of ways of doing the splice over here. But what I want to show you right now is you just press the splice button and you can see all the different splice options over here. But you just press the splice button and you select this bar and you right click and you right click again. And immediately, according to your given dimensions of put a splice at 8 meters, you can even stagger these if you want. And another one over there. So your splices are created very conveniently and very easily for you by this splice operation. Now, let's say we had a little column like this coming out from the side of the slab. So let's look at it from the top. And we wanted to embed these bars which are going inside the column to actually go inside the column, but not these last two because they're outside the column. We could very easily do that with the surface macro. We're going to go to the range operations, say conform bar to a point, select this rebar, and then select a point which will be about one clear cover inside this column. So I just press this point and I say dy50. And when I do that, right click, immediately this bar over here coming in is broken into two parts. One is what is left of it on the other side, and one is this one, which is exactly at the clear cover from the end of this column. Once we are okay with that, all we need to do is to go to the path operations and say I want to embed my rebar into another object. So what we do is we select this rebar at the end, then we select the endpoint, and then we show the two parts which need to be union. So I show it the slab, right click, the column, right click, and right click again, and immediately the bar is extended into the column. Once again, I have full control over the embedment length. So in this case, the default was 30 phi. If I make it 50 phi and I press OK, you will see that the embedment length changes. So these kinds of modifications after having committed the surface macro are very quick and very easy to do, as you can see on the screen. And it'll really make your job as a detailer very easy. So coming back to the fundamental theme of this webinar, which is that we don't want to be scared of concrete modeling or rebar modeling in 3D. We can do that with the modern technology which is available inside Comosys, and we can do that very easily, as you can see, as I've been showing you for the last I don't know how many minutes. But the point is that it is time to take that big step. We know that very few companies are into concrete and rebar 3D detailing. Very few, as compared. The steel sector is almost entirely in, but the concrete sector is unfortunately lagging for many reasons. But the excuses are no longer there. The visionaries among you will notice that the excuses are no longer there, and it is time for them to step up their game and actually make the decision forward. Now let's finally move on to the macros. And because what we want is that while we want a completely general purpose program, which will not let us down when we're doing those complicated and prestigious projects, we also want the program to help us out when we're doing the very simple stuff, like beams and columns and slabs and walls and single footings and all that. So on the right-hand side, you see what we call container rebar macros. And the reason why we call them container rebar macros is because when you run them, they create lots of rebars, and each rebar is actually mostly created by the surface macro. So it leaves you with complete control, just like the surface macro does, even after you've executed the macro. So they're like macros which contain the surface macro inside them. So as you can see, we have one for single beam. We also have one for beams on an axis. So you have continuous beams, and then you can place all the reinforcement in them with a single command. For tie beams, for shear walls, which have these two areas at the ends, which are reinforced like hidden columns, and then the reinforcement in between. Normal wall reinforcements, closed wall reinforcements. For columns, polygonal columns. For slabs, these can be slabs with holes. When you have the holes, you can have your hole reinforcement around them. You can have regions right under the columns which need to be strengthened with extra reinforcement. So these are like region reinforcement macros. Single footings, point flares, stairs, corbels, and whatever. So these are the container macros which will get your work done even faster than manual detailing for the normal, most frequently found cases. Now, just to give you an idea about how they work, let's try the single footing macro, for example. Just select that, select a single footing, right click to confirm, and then show it a direction for the main side. And the moment you do that, it creates whatever the defaults are for the single footing macro. And what you can do is you can select any one of those bars and press M once to go to the surface macro, but M twice to reach the actual container macro, and then press enter, and it will open up, and you can see there are lots of options inside. You can have top reinforcement, bottom reinforcement, you can have laser bars as well. But what I want to show you something is you can have your company standard set up for different types of situations. So here I have a 2 meter by 2 meter by 500 footing set up in my machine. I just load that. This is my company standard, and I say apply, and immediately my company standards are rolled out for that particular footing. Now, once we are happy with the single footing, what we need to do is we need to copy these rebars to the other footings. And while this case is very simple, we only have 2 rebars and we can select them very easily. But if you imagine a more complicated scenario in which a particular assembly has dozens of rebars and the neighboring assemblies also have their own rebars coming in, so selecting the rebars in this jungle over here might become difficult. So imagine you've got 25 rebars over here and another 50 coming in from other sides, from the tie beams and this and that. Actually, just selection could be a problem. So what we can do is we can select any rebar belonging to that assembly, right click, and say select same parent rebars. And immediately, whatever rebars there are which belong to that particular footing of the bar which we selected will be selected in a very, very conveniently. And once you have them, you can just right click and say copy to another object. Then you can select the source footing, and then you can select the target footings, and immediately your single footing or whatever it is that you're copying will be copied. Now let's move on to the column macro, for example. So I just select the macro and I say select the column, right click, and it asks for a foundation, which it might need to embed the starter bars. So I show it the foundation, right click, and the macro is run by defaults. All I need to do is just go inside the macro and see if I have any company standards set up. So I've got this one for similar columns. I just load that and press OK, and immediately my column is modified, or my column reinforcement is modified according to my company standards for that kind of a column. Now, this could be a situation where the selection I just talked about could become difficult. So you just select any bar belonging to the column, right click, say select the same parent rebars, and the entire column rebars are selected. Right click, say copy to object, show the column as the source column, and show the target columns and the other one. And your column reinforcement is created in front of your eyes. Now let's check the beams on an axis. So it could be a long axis. It doesn't need to be just 2 beams. It could be 3, 4, 5. They could be of different dimensions and different spans as well. All you need to do is just click on this one, select the first beam, right click to approve, select the second beam, right click to approve, nothing more to select, just right click again, and your beam on an axis macro will be created with your stirrup confinement regions, 3 different confinement regions and all that. And you can go inside and it will show you that you've chosen 2 beams. And for each individual beam, you can go to the data section and you will have complete control over the top reinforcement, bottom reinforcement, intermediate layered reinforcements, the stirrups, and basically the whole, I mean, everything you see on the screen, in the figures. You can even have different embedment details for each individual one. So basically, you have complete control over what you can do with the individual beams over here. Now, finally, for the container macros, because I don't have time to go through each one of them, but you do get the picture. Let me just quickly show you the shear wall macro, for example. You select the wall, you right click, there's no other wall to select. It asks for a starting surface, so I can show it this side surface. It then asks for an ending surface, I can show the other side. And then it asks for an inner surface, so I'm going to show it this inner surface. And the moment I do that, let me just look at it from the top. You can see that the container macro for shear wall has created a basic shear wall reinforcement very quickly. Obviously, these parameters are all modifiable, and we can open it up and we have the start area and the end cap start and the cap end, and we can have different parameters for each one of them and different longitudinal reinforcements and cross ties and this and that. So we've got a lot of detail over here. But the point of the container macros is to do very quickly whatever things are very commonly used in reinforced concrete detailing. But once again, at the end, I'll emphasize that you can always go back to your general detailing, and they're very fast as well. We're using the copies and the mirrors and mirror and rotate commands, etc. Using the handles, using the linear tapered, circular tapered, sectional commands. You just saw all that. But obviously, when you have your very standard beams and columns and walls and footings, then you can come back to these as well. Now let's move on to the subject of rebar drawings. And rebar drawings are of 2 types in Comosys. You can have them created automatically in certain template cases, and I will show them first. And these are completely automatic, and they're very nice and beautiful, and you can maybe sometimes tweak them a bit if you need to. So one example I want to show you is of single footings, which you can have in your project, and you can create automatic drawings for them. All you need to do is just select them and select the create drawing function, and I can show you the result by going to a drawing over here, which has not been touched. This is completely automatically produced. So you can see it creates the drawing of the footing. It takes the sections. You can see the sectional views for each footing. It gives them the numbering. Obviously, the numbering has been done. So it's very neat and clean. The drawing is almost as good as what you would do manually with your hand if you did an AutoCAD drawing. And this feature is very useful because every project is going to have some footings, and this method will also work for slabs or other types of flat foundations. Here we have some walls and shear walls. This is a shear wall with this area at the start and this area of reinforcement at the end. There are some normal walls over here with some holes inside them. And we have produced automatic drawings for these as they are the way they were created directly by the program without any manual modification. And as you can see on the screen, it's pretty neat. You have your type 1 reinforcement, which you see as lines over here. Let me turn on the line weights. And they've been very neatly dimensioned automatically by the program. You can see the cross-sectional areas of the shear wall over here, for example. They have been, all the position marks have been given. You can go to the material list over here, and you can see that every position has been drawn on the screen. So we have, I mean, this drawing is untouched. This is directly the way it was produced by the program, and you can use it directly as it is. Now, if you remember, we had discussed about embedded steel and how it's important, and you can have literally hundreds, sometimes thousands, sometimes even hundreds of thousands of these embedded steel pieces. And creating the individual drawings of each and every embedded steel is a really time-consuming task. It can be done in different ways. You can have a separate drawing for each individual embedded steel, or you can group them together. So here I have a little drawing for you in which I've put in those 5 or 6 embedded steel pieces and created the drawing automatically for you. So let me turn on the line weights, and you can see, so this is the embedded steel one. They've been numbered. Embedded steel 1, you can see that you can go to embedded steel 3, which has got these rag bolts behind it. They've been dimensioned. You've got embedded steel piece 2. This has some shear keys behind it. As you can see, the drawing is very neat and it can be used directly for manufacturing. There are some sectional views available to show the location of the rag bolts, etc. You can see embedded steel number 5, embedded steel number 6. So they've been dimensioned properly, and by a single click, you can produce embedded steel drawings. Like I said, you can put them into separate A4 or A3 sheets, or you can put them all into an A0 drawing if you want to. But once again, the bottom line is that it's a huge time saver. Perhaps you're wondering about the drawings of beams and columns and whether they can be produced automatically, because I told you that the drawings of these simple template type things can be produced automatically, but you can also do a complete manual production of drawings for complicated rebars. But if you're wondering about beams and columns, then I can show you that the beam and column drawings can be produced by Comosys pretty neatly. So let me go to this produce drawing. Let me turn, this one is, I think, the column. So if I turn the column drawing on, you can see that the column drawing has been produced very neatly. Let me turn on the line weight detail. And it's been dimensioned, the stirrups have been dimensioned, the levels have been given, and there are 4 columns or 5 columns, I don't know, and the sections have been taken. And you can see the sectional views individually for CL1, CL2, CL3, CL4. Those are the column marks. And then you have your material lists on the side as well. So as you can see, the drawing is very neat and clean. This has been produced automatically by Comosys. And like always, these drawings will save you a lot of time. Let's open the beam, one of the beam drawings over here. Let me double click on that. And as you can see, those beams which are going across 4 axes, so we can zoom in, going from column 1 to column 2 to column 3, they have been produced very neatly as well. The individual bars have been opened up below the beam, so you can see them and you can see the dimensions, and you can see the part marks very neatly. The sections have been taken. You have complete control over where the section will be taken, how the section will be, how many sections you want. Do you want a section everywhere there's some change, or do you want just one in the center? Those kinds of customizations are available. But what you can see, this is a 2A0 drawing because the beams are long, going through several axes. But the quality of the drawing is pretty clear from what you can see on the screen. Now, when we create rebar drawings, especially of elements like
slabs or walls, which are basically flat elements. In the drawings, we either have plan views like the one shown over here, in which we are looking at the rebars as lines basically from the top, or we have sectional views, as you can see on the right hand side over here, in which we are seeing some of the rebars as lines and some of the rebars as dots. So these are very typical to have a view, a plan view and a sectional view in your drawings. So now let's go to a drawing and see those plans and sectional views. So I've opened a drawing over here, and I can see this is the plan view, which has been imported from the model. This is one sectional view taken from somewhere over here, and this is another sectional view taken from the middle. But the point is that all your bars, let me turn on the line weights, all your bars are visible. So this bar is going from there to there. This bar is going from here to here. Each one of them has a certain range. This is only 2 bars. Then this one in its own region. This one has its own region. So they'll all have their own reasons. And from the sectional view also, we will see them as either lines or as dots. Now, when we create drawings, we usually have different styles of representing these bars in the sectional views and in the plan views. And normally what is done is that you take these bars individually. So for example, for this bar, what you will do is you will take it, and instead of showing all the bars, you will show one representative bar, and you would also show the range across which it is going to be placed. And similarly for this one, you will show one representative bar somewhere. You'll find an appropriate place for it and then show the range. And you'll keep doing that until you go through all the whatever 500 position marks you have in that slab. And that is time consuming. And then you would go down and do the same for the dots. So you will have a dimension of these dots over here, then another one for these, and then another one for these. And you'll keep doing that until you finally get to the end of the drawing, and that is time consuming. In Comosys, we have a feature which is very suitable for situations like this, in which you have plan views and sectional views. And what you do is you just select a particular viewport. That's all you need to do. Just select the viewport and press this auto annotate the viewport for rebars. And when you do that, let me just do that. Immediately, you see on the screen that all that thing which you were going to do manually, that this is leaving one bar and giving its range. So for example, you have this bar and it tells you the range, and you actually this range is selecting 2 bars, the bottom bar and the top bar. So what it does is do automatically for you what this could have taken you maybe 15-20 minutes, but it's going to take you a second now. You can do the same in your sectional view as well, by the way. And when you press that button, the sectional rebars have been annotated and dimensioned, giving their spacings and all that is required. And you can go to this view as well and just press the button again. And once again, your rebars have been dimensioned, and you can see the position numbers and the spacings and the diameters. Now, this is a huge time-saving feature. Because what you can choose to have your filters of just the top reinforcement only, and then another one for the bottom reinforcement, or all of them put together. So here you can see it's also labeled them as bottom and top. It all depends on how you filtered up the system, but the drawing. But the point is that what would normally have taken you maybe about 35, 40, 45, depending on your speed, obviously, has literally taken you a few seconds. And this is very, very useful.
For more general and more complicated cases, you can always create your rebar drawings manually as well. You can go in and you can dimension them with automatic dimensioning commands. When I say dimensioning, I mean auto annotation of the rebars so that they get their bar numbers, etc., and the counts and the number of bars, etc. Sometimes things can get really complicated, and you need to then go in and do some manual modifications to whatever has been provided for you. But your material lists will be produced automatically in all cases, and that's a major time saver even in the complicated cases. Here you see some eccentric foundations which are not centered. and they've been created, or the details have been done manually, and you can see that the results are very neat and clean once again. Rebar modeling is actually it will save you a lot of time if as far as the bottom line is concerned. It seems as if it's an extra time you spend on modeling, but the reality is that all that time which you spend on modeling does two things. First of all, it saves up immensely on your drawing creation time, because the modeling is the one which takes more of your time. And the second thing is the quality of your drawing gets much better. So there's no contradiction between your plans and your sections. If it's modeled correctly, if what you see on the screen is right, then the drawings will also come out to be exactly in accordance with that. Here are some more samples of rebar drawings. Another one over here. Another one over here. Some rebar dimensioning in the plan view. We have commands which actually produce these dimensions automatically as well. Once you have imported your rebars into the drawing, you can just click on a button and it will convert all the multitudes of rebars which you are seeing on the screen into these simple ones, which you can then move around if you want to clean them up even more. And you can even produce entire drawings made of nothing but material lists, which can cover basically the entire or whatever part of the structure or the entire structure, maybe for procurement purposes or whatever other purpose you might have. And that's it for today. Once again, I couldn't show you half the stuff I wanted to, but I know you all must be exhausted. I am. But I hope you're also a bit excited. If you're detailers working in some company, I hope you're thinking of going back to work and convincing your superiors about what you saw today. If you're decision makers, I hope I have succeeded in making you think about the possibilities which 3D modeling can provide and its potential benefits to your business. By the way, whatever claims I have made today are not claims of a software developer who has no grounding with the realities of the design industry. I have personally used almost every software under the sun, and I know what the constraints are. And our team has worked tirelessly towards eliminating those constraints. If used with the proper skill sets, Comosys will save you time and money. It will increase the quality of your work. And just as importantly, it will make you enjoy what you do as well. So with those thoughts, I want to end this webinar. It's 2 down, 1 to go. So the marathon continues. Next week, we will meet again. This time I'll be showcasing the finite element analysis and design capabilities of Comosys. Once again, I'm actually sorry for making you wait so long, and I hope it'll all be worth it for you and your company in the end. Stay safe and see you next week.